Hello everyone, welcome to the next tutorial. In this tutorial, we are going to solve some problems based on nodal analysis. Okay, so as you can see in this diagram, we need to find the value of Ix. Okay, let's say this is your reference node. Okay, and this is your voltage. Let's say this is your voltage V. So according to nodal analysis, what we can say is, like on applying KCL at this node, we can say that like on applying nodal analysis, so at this particular node, we can say that 16 minus V upon 2 is equal to V minus 32 upon 4 plus the current flowing from this branch, okay, which is equal to V minus 8 upon 4 plus the current flowing from this branch, which is your V upon 8. So on taking 8 common, we can say that it will be equal to 64 minus 4V is equal to 2V minus 64 plus 2V minus 16 plus V. Okay, so on further solving it, we can say that 9V will be equal to 144 and V will be equal to 144 upon 9, which is equal to 16 volts. Okay, so the current Ix will be equal to 16 minus V upon 2, which is equal to 16 minus 16 upon 2, which is equal to 0 amperes. So the current flowing from this particular branch will be equal to, so Ix will be equal to 0 amperes. So I hope it is clear how we are approaching this problem. So now let's solve the second problem. So in the second problem, we need to find the node voltages V1, V2 and V3. So let's say in this diagram, let's say this is your reference node. Okay, so on applying KCL at this node 1, we can say that, so at node 1, 10 is equal to V1 minus V2 upon 3 plus V1 minus V3 upon 2. So on further simplifying the equation, we can say that 5V1 minus 2V2 minus 3V3 will be equal to 60. Let's say this is your first equation. Okay. Similarly, for node 2, we can also apply the nodal analysis. So for node 2, we can say that V1 minus V2 upon 3 is equal to Ix, which is equal to V2 upon 4 plus minus 4 times of Ix. Here, this negative sign indicates that the current 4Ix current source has an opposite polarity. So also, we can also say that from the diagram, like Ix will be equal to V2 upon 4. It means that 4 times of Ix will be equal to V2. So on substituting the value of 4Ix in this equation, we can say that V1 minus V2 upon 3 is equal to V2 upon 4 minus V2. Okay. On simplifying it, we are getting 4V1 plus 5V2 is equal to 0. Let's say this is your second equation. Similarly, for node 3, so for node 3, on applying KCL at this node, we can say that minus 4Ix plus the current flowing from 2 ohm resistor, which is equal to V1 minus V3 upon 2 is equal to the current flowing from 6 ohm resistor, which is equal to V3 upon 6. Okay, so this implies minus V2 plus V1 minus V3 upon 2 is equal to V3 upon 6. So on simplifying it, we are getting 3V1 minus 6V2 minus 4V3 is equal to 0. Let's say this is your third equation. Okay, by using first, second and third equation, we can say that V1 will be equal to 80 volts, V2 will also be equal to minus 64 volt and V3 will be equal to 156 volt. Okay, so I hope it is clear how we are approaching these problems using nodal analysis. Okay, so that's all for today guys. I will see you in the next tutorial. Please do subscribe to the channel. Thank you.